to mute their mics, please. Thank you.
Thank you. Yeah, thank you, John, for the introduction. You might find it surprising that I'm using the University of Nottingham theme because actually I only took this lecture position very recently, and the work that I'm reporting here today was undertaken when I was still working at the University of Nottingham. So it is important that the credit still remains with the University of Nottingham. Therefore, I'm using the Nottingham template. Yeah, so I'm Xiaofeng Zheng, also known as Ken in the UK. So the piece of research I'm going to report is a very small field trial study, and I do hope that you find it interesting. So the topic is about the post-test in highly airtight passive house standard buildings. The content will include 4 different aspects. So I will give you some background introduction and then talk very briefly about the fundamental of the post technique. And then I will let you know the case study buildings that we have tested for this field trial, and then finally some test results. So the background is, so you might have heard about this before. So the airtightness is a fundamental building property which describes how well the building envelope is sealed. Other terms are also commonly used, such as air leakage or air permeability. So the air leakage are usually located at the joints between different building elements in the building envelope, such as between the wall and wall, wall and floor, wall and ceiling, and wall and some surface penetrations, such as the lighting fixtures and the kitchen drain pipes. Some of them you can see visually, but sometimes a lot of them are actually invisible. You might want to have a look around in where you live later. So this is a very simple example how air comes into the indoor space through the building envelope. So why air leakage is very important? So because it has consequences. It has impact upon our buildings on 3 different main aspects. It affects our indoor environment. It affects on how long we can use the building for. And also the last one is energy efficiency. Usually this is the one that we care about the airtightness because it affects how much we pay for our heating or cooling bills. Just this one as example. So different energy efficiency buildings usually have different requirements on the building airtightness. As you can see, the passive house usually has the highest requirement on the airtightness, and also because it has very low energy demand. But it is equally important for our indoor environment, especially when we are going through this pandemic, and indoor air quality is very important as well. And because of that, and the airtightness has been under spotlight in many different countries since 1980s. Here I just show you a graph of different countries have different regulatory requirement on the building airtightness. And just one point to make is because different countries have the requirement at different pressure difference. For example, Switzerland and Switzerland and France actually require the airtightness at 4 Pascal, but other countries mostly require at 50 Pascal. And Netherlands requires at 10 Pascal. But I would like to make it comparable, so I convert them all to 50 Pascal. You can see their how they compare with each other. You can see UK, Ireland, and Belgium are pretty relaxed on the minimum requirement, and other countries are pretty strict. And it might be very difficult for you to put a picture on it because it's pretty abstract. But if I use a coin, like a 5-pence coin, and to illustrate what this means. So for every square meter of envelope area, you're only allowed to have a hole size no bigger than this hole size. So for UK and Ireland, you can only have up to 1.2 times of this 5 pence hole. And then, for example, the Belgium is 1.4, and then Germany, Switzerland, France, and other countries have smaller, more strict requirement because the hole size is smaller. And then also US and Canada. So if you look at the passive house standard, it's much smaller. It's almost like less than 1/10 of this 5 pence coin. So this is the background of it. And so here I'm gonna introduce very quickly the pulse technique. So the pulse technique is University of Nottingham invented a method for measuring building air tightness at low pressure. The research has been ongoing for about 20 years, and so it's a team effort by up to like 10 researchers over these 20 years. So at the moment, it has been accepted by the UK government as a building regulation approved method for building air tightness measurement. So the technique is implemented by releasing a measured amount of compressed air from air tank over a short period of time, usually in 1.5 seconds, to the test space, and then monitor the pressure response in the space, and then also you monitor how the pressure change in the tank, and then you can calculate the air leakage characteristics of the building envelope. So these two pictures shows you what this pulse unit consists of. So the photo on the left shows you it's a tank unit. So we have the compressor motor that charges the air tank to up to 10 bar. And then we also have a pressure transducer that monitors the pressure change in the tank. And then we have a solenoid valve that allows you to release the air into the test space. And the one on the right is the control unit, where it has the data acquisition PCB board, and also it has a building pressure to monitor the building pressure change. And then finally, the data is processed and displayed on the screen. So this graph shows you the key measurement in the pulse test. So the red line represents the tank pressure, and the green line represents the building pressure change. So the overall measurement duration is about 6 seconds. And so we have 2 seconds background pressure measurement, and then at 2 seconds, we see a point where the valve opens, and then you can see that the pressure in the tank is decreasing because the valve opens to release the air. And at the same time, the air in the building will increase very rapidly until it achieves a peak point, and then steadily goes down. And then that's where the valve closes, and then we do another background pressure measurement. So using these two pressure variation and a couple of measurement of temperatures in the tank and the building, we can calculate the leakage rate of a building. And this happens in a very short time. Now I'm going to show you a video which hopefully will give you a better idea of how it works. Because this video is quite long, about 3 minutes, so I'm going to jump into the key point. So you can have a quick look. Can I just check with John? Can you hear the voiceover in this video?
No. Well, can you play it more?
Let me play again.
No, it's not.
Right. Let me just reshare it. I guess I forgot to turn on the included the sound. I forgot about that. No, not very good with it. Just 1 sec. Let me reshare it.
No worries.
Yeah, I forgot to turn on the include computer sound. Right. Now it should be okay. Let me try again and see if it works. 45 seconds.
Air leakage measurement method.
Yep, it's working now.
Low pressure air leakage measurement method, developed by the University of Nottingham and brought to the market by Build Test Solutions Limited. Through many years of research, product development and testing, Pulse presents a quick and simple means of measuring the air leakage of a building or enclosure directly at low pressure. Pulse uses a short release of compressed air to reliably measure air leakage at atmospheric conditions with minimal disruption to the building. The process involves the use of a portable compressor, air receiver, and controller. The air receiver is positioned centrally in a ground floor room and charged to between 3 to 10 bar while the building is prepared for the test. Air release and measurement itself takes less than 10 seconds. First, a small airtight vessel is sealed to provide a reference pressure, and a 2-second measurement of the background building pressure is recorded. This approach means that no penetrations to the outside of the building envelope are required as part of the test, and with that, the whole building fabric airtightness is measured. A valve on the main air receiver opens, releasing a measured amount of air from the air receiver. This creates a dynamic change to the internal pressure of the building, generating a flow rate through the gaps and cracks in the building envelope. The pressure and temperature in the air receiver and room are sampled at multiple times per second, providing a building leakage to pressure relationship. An additional burst of air.
So I'm going to stop here because the rest probably is not really necessary due to time limit.
Yeah.
And this video is also available on the YouTube if you are interested to look.
Thanks.
Yeah, I'm gonna keep going. So just a bit of a challenge for testing Passivhaus. So here I just put a typical post test in a typical UK house and a test in Passivhaus standard building. So if we just ignore the red one first, look at the black one. So we can see two curves. So the one on the top is the tank pressure change, and the one on the bottom, which is a pulse shape, is how the building pressure responds. So if you look at the pulse shape, so basically we only open the valve for 1.5 seconds. We can capture the whole pulse shape because that's very important, because that's where the quasi-steady period happens, and that's where we analyze the data. Because the percentage of unsteady flow is very small, so we can get accurate measurement. So if we use the same setting for testing the Passivhaus, we get totally different curve. So if we look at the 1.5 second, you can see the red one. We only capture the very small bit of the whole pulse shape in the Passivhaus standard building. So it's important we open the valve for a little bit longer. So for example, up to 4 seconds. So in that case, we can capture this pulse shape in the Passivhaus standard building. So that's how we have to make some adjustment to the pulse operation when we test Passivhaus standard buildings. So now I'm going to introduce you the case study buildings. Just a bit of background. So basically, the reason why we conducted this field trial study in a Passivhaus standard building is because we need to gather some evidence that Pulse is able to test Passivhaus standard building as part of the submission to MHCLG, which stands for Military Housing Community and Local Government, which is the UK government that is responsible for the building regulation. We want to convince them the Pulse technique can not only measure the standard or typical UK buildings, but also it can measure a Passivhaus standard building. So now the Pulse has been accepted as a approved method for measuring new UK dwellings, including Passivhaus standard. So this will become, I think, will become valid, or I think will happen in this year, applicable to England and Wales. So here, the example of this case study buildings, we have a range of volumes. So I highlight these two we actually covered a very wide range of volume in terms of the building size. So we have the minimum is 94 cubic meters, and the maximum we have 636. So it's a very good range and should be very representative. And here I just show you some photos of typical buildings. So the one on the top left is a new build flat, and then the one on the right is a new build terrace house. It's a 3-story actually, and the one on the bottom left is it's an unfair building. Basically, it's an existing building that have been retrofitted to passive house standard. And then the one on the bottom right is a new build detached house. So here just show you how the building is prepared when we test the passive house standard building. So the photos on the top right, actually, if, in terms of building preparation, compared to a normal or typical UK house, it is much easier to do the building preparation. You just need to do it according to standard, keep all the internal doors open, windows closed, and we do a bit of sealing up. So the reason I would say easier is because you just need to take the filters out and then seal it up, and then or you can just seal it outside the vents. The two photos at the bottom left, you don't usually need to do that to seal up the sinkhole or bathtub. The reason we did that is because this house was not used for a long time, so the U-bend in the sink actually dried up. It's created a hole to outside, so it's important to seal them up. So this is a building preparation for the passive house, and this is the setup of the equipment. So the photos on the left are shows you how the post unit is set up in the passive house standard building. So basically, we just need to put it in the center of the building, and then we keep the building envelope just as they are. We don't penetrate them. We keep the building integrity. And then the one on the right, because we would like to compare it with the conventional method, which is blower door, if you have heard of it. So the gentleman in the back is very famous. His name is Mr. Paul Jennings. He's in the UK, we call him the blower door guy. He's very experienced in testing houses. Actually, he's also very experienced in testing passive house. You can see the panel, the blower door is installed in a window, because he realized it's very difficult to achieve a very good installation, because blower door has to be installed in an existing doorway. But he especially made a window-mounted rigid panel, so where he can achieve very good well-sealed installation to minimize the difference caused by the installation of blower door. And so that's how we try to minimize the difference between the building preparation when we do the post test and blower door test, so we can get a little bit more comparable test. So this is the results. Just give an example. I know it's very difficult to have a direct comparison, because post test, if you look at here, we test the building at lower pressure, and blower door test the building at high pressure. So people always ask, how do these two compare? It's very tricky question. It's like compare apple with a pear, because they're doing two different things, and also the nature, how the building is tested by these two methods is slightly different. For example, the blower door has to be installed in existing doorway, so basically it doesn't really measure the leakage of the blower door, or no, of the door or the window, but the post actually maintain the building integrity. So that's the difference. But in reality, when we do this comparison, we try to minimize the difference between these two. So if the difference is minimized and we test the same building, we can see these data points actually follow the same trend. But having direct comparison is always unavoidable. So we have to make some compromises. We do a bit of extrapolation. As we know, when we extrapolation up or down to a measure range, error occurs. So we did some comparison, extrapolate blower door down to 4 Pascal and have direct comparison with post. So we can see some of them actually agreed pretty well with each other, but some of them is the difference is slightly larger, which is expectable considering what I just said. And it's the same for the results at 50 Pascal when we extrapolate post up to Bordeaux. So it's kind of a comparable test results. So the finding is so the post technique can measure the airtightness of passive house standard building, but with an extended valve opening time. And also, it is a bit challenging to achieve a like-for-like comparison between the two methods because of the way they're implemented is different. But we can achieve comparable test results when the difference in the building envelope condition is minimized. Just being conscious of time, I'm just gonna wrap up with some update on the commercialization side of things. So basically, right now the IP of the post technique is owned by the University of Nottingham, and it's been licensed to build the test solutions, which was formed by 3 project partners from one of the UK projects. And we also received funding from EPSRC Horizon 2020 and the Department for Business, Energy and Industrial Strategy. So a lot of support in this whole journey. And so this is the website for the joint venture, if you're interested to look at the product. And so this is where the post technique is at right now. So the top left photo shows you the latest prototype. So the first one on the left is a control box, and the one in the middle is the compressed air tank. It's a 40-liter tanks that is enough to test most UK new dwellings. And the one on the right is a portable compressor, which allows you to charge the compressed air tank to the pressure level you need. So it can be carried by one person, and the one on the top left, sorry, the bottom left shows you how it is set up in a test. So we've been talking about the test using post technique in dwelling, but for non-residential buildings, because the size is a lot larger and sometimes it's leakier, so one tank cannot do the measurement. So we need multiple tanks to be linked together, and then we distribute them through the whole space and evenly. So we release the pressure, release the air into the building simultaneously to achieve a uniform pressure distribution. You might recognize some of you from University of Nottingham is in the Marmon Cafe, and in combination with the computer room on the upstairs. So we did some initial case study. Yeah, so that's my presentation. So regarding the John, thank you for creating the opportunity for like proof of concept prize. So so this post technique has only been used in Europe mainly, and in Asia Pacific area there's only Australia, I think New Zealand as well, and then Taiwan. We haven't got a post technique used in mainland China. So for anybody who is interested to possibly start some collaboration, maybe we can try to apply this funding together from John, and then hopefully we can do some collaboration and see how it goes in the Chinese market. And yeah, thank you for your attention and time. Back to you, John.
Thanks again for your presentation. I think it's a good example of how you turn a technology or an idea, and you showed how the journey of getting it commercialized, fully commercialized, and working with different industry partners, and finally getting funding. And I think we will have some questions about that, which you can share your knowledge and your experience to the younger researchers or PhD students who might want to take that step. So anyway, I think we still have all the speakers. So I invite you guys to turn on your camera, and we will have the discussion and have some. We have some questions in the chat, and I'm sure Sally as well have prepared some questions. think we have. I don't know if we still have Didem and Shangxi in the chat. Yep. So I think, hello. I think we can start with Murtaza first. I think we have a lot of questions for Murtaza, and everyone can really share their screen. This is the last session for today, and I think if you guys are around anyway, we can extend it further for the discussion. I know the session is only up to 11, but if you are free, feel free to stay and ask the questions. And towards the end, we will even talk a little bit about the proof of concept if you have any questions. Ling, do you want to start with the questions for Murtaza?
Okay. Yeah, I think there was a couple of questions for Murtaza. So now I think I was also asking about, because I think the work was very interesting on contamination transmission, and I was just wondering if you intend to test it with virus, and if that's the case, how do you actually test it with virus?
Yeah, I would say that is a future proposal. When I started my research, it was more to do with transmission of pollutants only. So pollutants, in my case, I was referring to PM particles less than PM10. So I used the tracer gas SF6, which is good enough to mimic PM5, PM1, and finer particles. However, although from yesterday's discussion, Professor Hong did mention that virus, the size of the micron is such that transmission of tracer gas can suffice for transmission of viral load also. However, there are multiple parameters associated with the virus, and it cannot necessarily be, the results can't be put forward for the same case as for virus as for pollutants, because you have lifespan of that pathogen, and it also requires humidity or some other host elements to survive. So you can't really translate results from pollutant into pollutant study for a viral study. However, the pattern will be similar, but the actual quantity could vary, and that is a matter of further research in my project.
Okay. Conrad, I think your hand is up. I'm not sure if you have a question for Murtaza.
No, it's for Sally.
Oh, okay.
Oh, okay.
We'll come back to it later. And yeah, there's another question for Murtaza. I think you answered that on the pollutants considered for your model, right? The CO2, CO.
Yeah, I think Antti, we cannot go through all the questions for Murtaza, but you can obviously comment on that later. But we can select the question from Antti. Antti, do you want to ask Murtaza directly that question?
Hello, everyone. Yeah, thanks for the opportunity. Murtaza, I had one question I wanted you to attend to. You said, how can you expand indoor spaces? You mentioned this as one of the solutions to curtailing the impact of pollution within the in an indoor space. So how do you expand that, given the very dense city settlements? Buildings are densely spaced.
Right. Sorry, mention of indoor spaces, I was literally mentioning how, the further work should investigate. So I had used only a couple of extreme cases of indoor spaces, like one located at the far end of the canyon and one in the center. So what I meant was there will be finer nuances of transmission if I introduce more indoor elements in the building. Those characteristics have yet to be assessed in detail. So those were one of the few things which I would like to do forward for my research. It was not directly the answer to your question, but I guess I placed it in the wrong context and you got the wrong idea. Sorry.
I think you can also link that, Murtaza, to what Tim was talking about previously about having those additional spaces, like more innovative ways, like sky gardens or sky courts of expanding, right. Not only expanding inside. Okay, so let's move to Didem. I think Ling asked a last-minute question about the. Ling, do you want to?
Okay. Yeah, so I mean, at this session, I think it's quite interesting because we have a lot of different talks from different perspectives. And for Didem's work, it's a very different nature of work where you're trying to, tell the audience what to do, what to consider before it's too late. So I was wondering, when writing, is there a specific audience you have in mind when writing the book? And based on all the talks we have today, do you think we are moving in the right direction, or what more can we do to speed up and go in the right way for the future of Britain?
Thank you very much, Ning. So I just want to first perhaps clarify. I am a computer scientist, and I work with cyber physical systems. My research generally focuses on data science for collaborative robots, for increasing interoperability between different type of systems, which these systems are very complex today and so on. But at some point in my life, I have been trained to become a future strategist, which was like a long journey, and completely shifted my mindset from not only focusing to solving specific, very well-defined problems, but also taking a step back and looking at what are the problems, what is the question here. So that made me to really reconsider everything, including my education at one also point, but also I teach, I do research. So I feel myself also responsible that we all belong to this environment. So it is my responsibility to nudge and try to change things around this environment. I think engineering education and research is very well, and also been always very good to solve problems, and that is why we are engineers and computer scientists. When we have the problems, we know how to solve it, and that's good. But the world is complex, and it is getting more complex, and in different situations, like pandemic, we don't know the problems, and we are really not that good to fight with these kind of things, because we want someone to tell us that, oh, this is broken, so I can fix it. But sometimes we need to take that mindset and change things and try to see what's going on. Why is this happening? So working in a technology and coming to the civil engineering just 2 years ago at Cambridge made me to realize that people in construction, civil engineering, infrastructure industry is seeing the technology also something that will solve everything. But if we don't know how to ask the right questions, we will never be able to solve problems. I do data science. I know that people love talking about data and machine learning, artificial intelligence, and we all think that it will help us. Data is just bits. If we don't know what to do with it, if we don't know how we should use it, we will never be able to do it. So we did this study, me and other 14 people in Cambridge. We put our days and nights to do and write this book, mainly for this reason, because we think that we need to also take a step back and look at what we are doing and what our decisions of today may change the future, and if the decisions that we are taking is enough to change the future, because one being climate change, obviously it is not enough what we are doing now, so we need to change this. So first I wanted to clarify where I am coming from. I didn't get education on imagining futures. I am a computer scientist day and night. What I do is completely different than laying down and thinking about what the future may look like. Unfortunately, last 2 years we had done lots of things, but I don't see that we have changed anything. And I congratulate all of the speakers from the work that they have done. They are all wonderful things, but when we take a step back and look at the world, I don't see that a lot of things have changed, and unfortunately not towards the world that in the book we push people to imagine and admire and work towards. We are very far from that. So thank you very much.
Thank you, Didem. Do you have any?
Is there any more questions for Didem?
I think Hong Zua got some, and Sally as well. So let's start with Hua.
Yeah, and thank you for introducing that book and following your answers. I'm totally agree with your opinion, and also see you also produce a children version book. That may be a good way to encourage a young generation get this kind of mindset and knowledge at the beginning of their life. So how your project can let the teenage or even younger children engage in with this topic? Do you have any other further plan to engage the community with a young generation?
Thank you very much for the great question and comment. So our audience was always anyone and everyone, because we talk about the future of Britain and built environment. Everyone has schools, houses, uses the roads, gets the services that infrastructure gives and so on. So everyone should be included to the discussion also. For that reason, we wanted to have the book in different versions of the book to be reached by different age groups and people. So the children was always in our mind. And at the end, when we were invited to the Cambridge Science Festival, where lots of students are invited to listen the research results of scientists from Cambridge and so on, we took it as an opportunity and built this interactive game where they go to a website and they choose different roles and make different decisions, so end up being in different scenarios. This has been also invited to the BBC radio. The person who narrated she's from also UK, and young children. She was just unbelievable with a perfect Manchester accent and everything. It was great. So we try to encourage, and during the science festival invited, I guess we had more than 80 children working on a Miro board and writing their stories, and it was just incredible for me, for instance, to see that as a researcher, being able to see how the kids are imagining future. I can say that they were much better than grown-ups. So I believe that it is also for any researcher, any scientist, it's a great exercise to try to make what we think, what we work, understandable even for the kids, being important even for them, touching their lives also. So I think that was an incredible experience for me. Thank you very much for the question.
Thank you.
Sally, did you raise your hand? Yep, go ahead.
Yes. So Didem, first of all, congratulations on the very exciting research, and also reading your autobiography about your bio about equality. I very much enjoyed it, which is reflected in your response now about children, and also in your actual work that you have included so many different experts from different backgrounds in your research, which brings me to my question about expertise. So I was very much interested in the methodology you have applied for your research. If I understand correctly, so you're asking, so you have included one expert from each background, and through those discussions, through discussions at them, and through those discussions, you have actually come up with these scenarios. In case my understanding is correct, then my question is, say you had one architect, from my background, one architect. What if you have asked another architect, you know, not this person, another expert? So would it not affect your outcome and your scenarios quite significantly? Thank you.
Thank you very much. We had 16 participants and 2 facilitators. The methodology itself requires a group of to maximum 20 people to work together 2-3 days to firstly point out what are the trends, what are the uncertainties, and make a list of them, which I talked that we choose 34 trends that we believe that it will affect the future of built environment. For instance, some of the speakers talked about digital twins. We said that digital twins will be somehow related with or affect the future of built environment in 2040. But we also looked at other things like taxation, like education, like working patterns, robots, and so on. So everyone surely chose the trends that are very much visible from their perspective. I'm a computer scientist working with cyber-physical systems. I surely said digital twins and robots and other things. And architects taught different things. So you are right. If we had perhaps other people, maybe they would not choose robots or digital twins, but maybe choose something else. But also we didn't only decide 30 influencing factors at the beginning. At the beginning, we collected more than 100 trends. But then we had to, another 6 months, work on these trends and check all the resources, which says that what Didem said, the robots will be important in the built environment, has been also said by other resources, being scientific papers, journal articles, conference articles, news, books, and so on. So anything and everything that we included at the end, that 34 influencing factors, has been later checked and approved or somehow included by other references. So what participants said plays a big role, but they are not the last words. That is just the beginning of the work. The rest, researching and finding resources to follow that discussion has been much longer and more difficult work than just collecting people's ideas.
Thank you very much.
Thank you.
Thanks for that. Now, let's try to move on to Xiangxi. Now a bit more technical question about your research. Very interesting presentation. I was wondering about the prediction accuracy of the approach. What is the typical accuracy?
First of all, thanks for your question, John. So I think this is about the last example I gave in my presentation, right? So I think first of all, let me just better explain what we mean in the last example. So we know that the pandemic has changed the pattern that people use the building and also the system, and of course the energy consumption would be, the pattern of energy consumption would be changed dramatically after the pandemic. So actually what we do is to explore whether the historical data can be still used, and it is still provide some insight into the prediction of the energy consumption. So what we do is we classify the daily energy profile into classes. So as you can see, we we gathered the data for the last 1 year from January to December, and we classify the daily energy profile into 6 clusters. And as you can see, before March, which is the time when the whole country gets into lockdown, it shows a specific pattern. So in the color of yellow and red. And after March, almost all the buildings are shut down. I mean, the teaching building and the labs are shutting down, only keeping a minimum level of activities there that is related to the COVID research activities, like in our pilot building, which is the 3D printing research, which is to help to make ventilators. So that is only a minimum set of activities. And what we found is that after June, June is the time when the university said the building can get back to the new norm, which is keep also a very minimum activity there, but in a more diverse way. So some teaching, some research, and different researches, not only the COVID-related researches happened there. So we found that the profile gets back to the old cluster, which is yellow and red, which is labeled in yellow and red. So what we want to say is that to predict the energy consumption, for instance, after June, it is okay to reuse the data before the pandemic. I mean, the historical data is still applicable in this period of time. Only the conclusion we want to draw is that this is to make sure that the data, the application that we develop is still applicable post-pandemic. We need to have better understanding of the people's activity and their behavior. And if that is understood well, then we can say that the predictor that's trained before the pandemic can still be used. Of course, updated with the new data coming through as well. But we need to at least to rule out or get rid of the data that is between the March and June, which looks like a new pattern. It's a COVID situation. It's a COVID pattern instead of a normal pattern, which diverse activities should happen in the building. So the detector. So and another colleague is doing on the prediction. So for the building level prediction, I think the accuracy is already pretty high by combining the weather and other contextual information. I couldn't remember the accurate number, but I think it's around 1 or 2% of the IMSE. So, but in this research, what we want to say is that this is the getting better understanding of the people building interaction is a very important premise for adopting digital twin technology, and also the historical data, and reuse and make best use of the historical data. Yeah, if that answers your question.
Yes, thank you very much. I think we have a raised hand. Auntie, you have a question for Xiangxi.
Yes, I do have.
Yep.
Thank you.
Go ahead.
However, that question, mine looks much similar to yours. So I want to strengthen your question. In terms of the model he used, I would have loved to, because this depends on the behavior of the customers, which is based on different parameters. So the model you used, have you been able to compare it with others? I mean, look at the prediction accuracy of your model vis-a-vis other models. And then that's one. Sorry, and that's one. Maybe you handle that. Then the second one is your prediction is based on a time series of forecasting. It's time based, and but I do understand that there is a short term and long term forecasting. Have you been able to really look at the accuracy? Just trying to look at the short-term versus long-term forecasting. Which one works better? Thank you.
Thank you for the question. So so for this piece of application that we demonstrated, we work on the short-term forecasting, which is with the time interval of 1 hour, and we are forecasting the we try to forecasting the energy consumption of the next next day, so that we can understand the evolving the demand during the period of interest. So that is the to answer your second question. The first question about the is it about a prediction technique or something like that? Is it? Okay,
yes,
so
yes.
Okay, so in terms of the prediction techniques, well, I think this is the piece of work that is done in our group as well. So we have tried different prediction time series prediction, because that is we have handful algorithm that could be applied in this algorithm. And what we try to do is a tricky thing here is this is also published in another conference paper of our research group. So a tricky thing to make the prediction happen in the building is that we understand that the timestamp for different parameters could be different. Like for weather, the weather data coming from the we use a data source called Metro Blue, and for the energy consumption, we use the data from the BMS system, which is in the interval of 15 minutes. So the to make sure that the prediction happened, covering all the data that is in different time interval, we try to use the ordinary neural ODE, which is a new technique that could handle data with different interval, so that we do not to do the data interpolation first before the prediction. And this is a new technique that we'll try, and it turned out that it can so it shows a promising results. Yeah.
All right. Thank you.
All right. Thank you. Moving on to Yi Shu about her work on the working from home perspective. Ling asked, well, I have that same question as well. How did you track the movement in the space? Because you showed those colorful pictures. To us, we see that as like contours that we get from simulations. But we are wondering, how did you get those colorful lines in your room schematic?
Yeah, thank you for the question. Well, it's an important question, but as you probably have already found out, that unlike the other researcher in our section today, our main concern might not be the quantitative accuracy. So to answer your question, first, no electronic sensors were employed in our research. So how do we do it? First, we ask our interviewees to draw a continuous single line on the paper while recalling and reimagining their movement in their room. For example, starting from they lying on the bed and extending out into the world of their room. And their drawing action was recorded by a video camera. So why are we choose this way of tracking the movement? The reason is closely related to our research intention as well. Why don't we use a sensor or something more accurate to record it? So as architects, I think our traditional methods of conceiving and representing space through the architectural plan are mainly allocentric. They're based on a totalizing map-like view. It shows the building as a complete and stable object, while we here try to challenge this by also incorporating partial and temporal representations with egocentric characteristics. So our intention was to understand and redraw the work home from the diverse perspectives of the individuals who inhabit the dwelling space. For example, my body in its exact position is the point from which I constructed a spatial understanding of the world in front of me. By using visual landmarks, I navigate a space by moving from one point to the next. So in our research, we try to develop a kind of drawing and tracking way that overlaps both allocentric and egocentric representations. So, well, I hope that answers your questions. That's how we do it and why we do it. Yeah.
Yeah. Thank you very much. That's an interesting.
Thank you.
For Sally, Ling got a long question there about your experience.
Adam, I can answer if you like.
Yeah.
So, Ling, you have got two questions for me. I go for the second one first, and the first one, which is about collaboration, I want to open it to the panel. So, panel, you may want to have a look at that question. It's coming your way. About, I quickly say that, how do you enhance or encourage collaboration, and how do you, as an early career researcher? So, I'm going to open that for all of us. The second question, Ling, you have asked me is about a very difficult question, actually, you've asked, I should mention. Living in hot and humid climatic conditions, and how do we, go for mixed mode, or how does it work? Good question and tough one, because hot and humid climatic conditions is one of the most difficult ones to resolve using passive design of the building, because I'm the program leader for sustainable architecture studies. So the hot and humid climatic conditions is always the one that I feel like, okay, extra care needed there. Why? Because specifically if you're closer to that equator, then you're not having enough day and night temperature changes. So, many strategies already go out of the window. Such as thermal mass is too humid, so evaporative cooling is out of the window. So a lot of very good strategies go out of the window, and also there are not much seasonal differences either. So the temperature is kind of 30 degrees all year round, more or less, depending on where you are. So how do we deal with a climatic condition as such, and high humidity as well? So when I went to Hong Kong, I couldn't tolerate the humidity, and for the first time I got headaches of just, walking outside. So I give you a few things that I encourage my students to do, and how mixed mode can fit in, basically. So traditional methods are usually encouraging ventilation, natural ventilation, as much as possible. And I think that may be key to even a mixed mode building design. So I have never thought about this question, actually. I'm coming up with ideas right now. So how practical they are, or maybe I'll come up with better ideas later as to be tested. But at the moment, what I think is a mixed mode can work in the sense that rather than saying seasonal, performances, winter heating, summer cooling, or autumn, spring kind of natural ventilation, I would suggest natural ventilation for as much of possible. And if the occupants felt cold, maybe going to heating mode, and if they felt warm, to go to cooling mode, but as much as possible to encourage natural ventilation, which comes back to design of the building. So single-sided ventilation may not be the best way to resolve that specifically in such conditions. So various different ventilation systems like cross ventilation that Mortaza is working on, for example, stack ventilation, different types to encourage it. It needs to be carefully considered. So I would say that may be better. And also not just ventilation, but other strategies like shading and plants and other things. So if you wanted to continue that discussion, maybe email me and we can continue that. I'll end it here. The other one, which I'm going to open it to the panel, is about collaboration. So for early careers, how do they start the collaboration? I would say two things from my personal experience, and I'll pass it on to you guys. One of them, well, the key point for both of them is take a deep breath, be brave, and step out of your comfort zone. That's my key message here. One of the ones is change universities. So look for a postdoc. If you're in the UK, you have 2 years post-study visa, great. So look for a postdoc elsewhere. I was offered one postdoc in Edinburgh University, one in Leeds. I loved Edinburgh, but I took a deep breath and moved to Leeds thinking I'll work with new researchers in a new environment, new opportunities, and that worked really well. As I met John, as I was mentioning, and we worked until today, actually. We are still collaborating a lot. So change universities, look for opportunities, create opportunities, yeah? You can do that too. The second one is conferences. Now, online conferences is new for me as well, so, well, you may contact people, why not? Email them. In face-to-face conferences, in case they come back, be brave. Go to the speakers that you actually enjoy their research, have a chat, start a chat, and see how it takes you. I work with Professor Home Rijal in Tokyo City University. It took me nearly 3 years to establish that collaboration. I was too shy. He's quite well known, and for me to approach him. But what I did was, well, every 2 years we met in the same conference, and I kind of shyly suggested, would you like to write a paper with me? And, you know, as much as, you know, you want to be involved, and he welcomed it. And last year, 2 years ago, actually, I went to Japan. I got this funding. I went to Japan, stayed there for a month and learned so much from him. So collaboration, I cannot tell you enough how important it is, particularly interdisciplinary collaboration. Now, I go mute. Can I pass it to the panel and your expertise on the topic and how you did collaboration or you encourage it?
I think Conrad raised his hand. Conrad.
Actually, I was about to ask the same question as Ling, but she answered already in the chat. But I would just like to relay also the same concern because I come from the Philippines, also Southeast Asia. It's hot and humid all year round. We don't have 4 seasons. So offices and schools have air conditioning all throughout the year. Now, because of the pandemic, the government is encouraging to do it outside, but it's too hot. And I think there's a problem between they're encouraging more natural ventilation, but at the same time, people sacrifice their thermal comfort just for that. So it's a dilemma right now because the economy has shut down because of this. And we don't have any, indoor dining and restaurants are prohibited because they have air conditioning all throughout the year as well. So they don't have any al fresco dining. If we do that, then it will be too hot and people will not go. Yeah, so I think it's a concern actually for the future. For Singapore, Manila, probably Dubai as well. And it's a big chunk of the population. I think in Southeast Asia, it's a tropical climate, and it's about 500 million people live here. So it's a big, yeah.
You're absolutely right. And I think there are different building typologies. So my suggestion was mainly for office buildings, which is in Ling's question. But if you go to more public buildings, as you were mentioning, then occupant control doesn't mean much because your occupants are constantly changing. except if you're designing for the kitchen in that restaurant that you know who is going to work in there, but the actual dining room, probably people who come in are not going to be brave enough to open the window. So a more centrally operated system is needed. But now, can we still design passively? Well, that's what I encourage when we are teaching sustainable architecture. But thank you very much, and I hope we find new and better ways to encourage this, basically.
All right, thank you.
So I think you have a hanging question there, Sally, to the rest of the group about collaboration, about what you think about. Yes, Sally, go ahead.
I'm sorry, that was a mistake. Yeah.
Yeah, does anyone want to respond to that?
How did you find your collaborators? For example, Dr. Ken, when you collaborated with so many different partners as part of that big project, which was very exciting, how did you approach them, or how did you get involved with it?
Well, thank you for your approval. And basically, it's kind of a, how to say, research projects you have to participate in. And so when you attend, for example, you do one research project, and it links up and open up more doors to further research project. And for example, the first one I did was the Innovate UK project. Was about 5 partners altogether, and 1 academic and 4 other industry partners. And then because of that project, we managed to get another European project, Horizon 2020, which was include about 20 project partners. So basically, one door opens to another, and then we managed to promote the POST technique across the whole Europe. And then we got a lot of customers as well, and they bought the POST technique and used it in their research, and also in their company, like consultancy and some government body as well. So yeah, so I think from my perspective, I think like you said, Sally said, just step out of your comfort zone and just get in touch with people. If you're not working on a research project already, and when you work on a research project, and make sure you be active, try to look for opportunities for further collaboration opportunity in future. And yeah, I think that's my understanding. Yeah, I hope that's useful for you guys. Thank you.
Thanks, Ken. We're way over the limit of the time. I don't know if you guys have to run, but I think we've asked a lot of questions. I think the only group we didn't ask is Paige and Xiongyu, and I think we can ask that like last question for today about that problem that they've raised about having air condition in hot climate. So how does your approach? How can you use your approach to apply it in hot climates?
So our approach, we tend to, so using the camera to detect like anything within a building space, and then the system recognizes what's happening. So how many people, how many, so equipment, so heat gains within the indoor environment, then also to work with outdoor sensors. So like knowing what's the weather condition outside, the humidity and indoor air conditions. And so once those 2 main factors are known, it will tell the system how much, like what sort of operations the air conditioning needs to give out. So if there's less people, less equipment, then obviously it might be a higher temperature to meet the set point required. So it all depends on what type of building it is, and also which area it is in.
Thanks, Paige. There's a hand raised. Auntie, do you want like final question? If you have one more. Hello, Auntie. Yes. Did you raise your hand?
I
yes,
do have.
Go ahead.
Yeah, the page and showing you. Your research is good. I like it, but I have my concerns with the applicability of your research. You see, your work proposes is sort of a supervised deep learning approach to estimate occupants' behavior. So I see this as interfering with the privacy of individuals. So that raises ethical questions. So how have you assessed this? Have you figured this into your research?
So yeah, the main privacy issue will be the use of the camera for detection. We will overcome this by not detecting, saving or recording what's happening inside the building space. So only during the deep learning profile that I show, only that sort of data is recorded. And also because it's real-time controls, no historical data will be required to be saved through the camera.
All right.
Yeah.
All right. Okay. Well, anyways, thank you. I really appreciate you guys for staying and answering the questions and having a good discussion. I hope that's useful. And Ling, have a final request before you guys go for your lunch. There's a poll over there for best researcher, best presenter. So if you could do that. Conrad is going to close the session and also the workshop for today. We have another workshop tomorrow. However, that is really like the time is going to be in China, so it's going to be very early. But we are going to upload all those sessions, recorded sessions, because one of the things that we're having in this workshop is the proof of concept prize, and it requires having collaboration. And there are some interesting talks from the China side, which you could maybe have some collaboration and find partners for your project. But anyways, thanks everybody, and I'll see you later. Have a nice weekend.
Thank you, John. So Ling requested for you to vote for the most interesting presentation for this session number 7. John, do you have any, or is it? Do you have to say something about the what do you call that? The prize?
The proof of concept prize. I'm here anyway. If you guys are around, if you have any questions about the proof of concept prize, Ling is here also. If you have any questions, feel free to ask it now, and we're happy to provide some guidance on the requirements or any questions that you have.
Oh yeah, I have a question.
Yeah.
So regarding the proof of concept prize, it has to be a one from China, one from the UK to collaborate, and then each side get up to £6,000 support. Is that correct?
Yeah, it's not a requirement to have a partner from China.
Oh, it's not a requirement.
Yeah. It's I mean, it's good. Like, I mean, this is going to be assessed. We're not part of the panel. We're not going to be the judges. It will be Jack Pretty from UCL and another professor from China. So, but obviously they could take that into account if you have a partner. It's better in terms of the assessment.
Okay. Right. Let me think about it then.
Yeah. Well,
thank you.
Anyone else from the audience?
Murtaza has a question.
Murtaza has a question.
Deadline.
Yeah. I mean, this was a very short time when we got to interact with different presenters and other people from other universities. So I was wondering if there is an extension.
I think you mute your mic.
It's unmute.
Oh, it's okay now. It's okay now.
Yeah, so I was just wondering if there's a possibility for extension of deadline. Getting to know people right now and having developing the POC will take a bit more, few more days. So do we have that coming in effect anytime?
Deadline actually in September, so that is 1 month after the workshop. If
I will. Oh, is it September? I thought it was okay. I thought it was end of August, so it's okay. I'm mistaken.
We're just doing this workshop so we can start interacting, and then later on, if they approve, we'll share the email. And if you want to use the forum, you can, and just to get to know them, talk to them, and then you have a month to develop something together. So hopefully that's enough time.
Yeah. The main reason for that is because the money has to be spent by end of this year, which is December 31st, and obviously we want it to be a bit later so that you can think more of what to buy and what you need to budget for. But that's because of this prize, which is the Newton Fund, and it has to be spent by end of the year or it goes back. But if we can ask them to extend it to February, then obviously this will move. We're asking them, and we will see what happens. But as of now, it's September 28th.
End of
September.
Yeah. And another 2 weeks for the judges.
Yeah. Murtaza, you raised your hand again.
Yeah, sorry. So, I mean, the other thing I was curious is, since many of the guests who joined the meeting were external to Nottingham University, so they do not have access to the chats anymore. Will you be sharing other contact information for all of those participants at a later point? I mean, some of them did put in the email ID, but I'm not sure if everyone did that. So do you have any suggestion how that we can connect with them?
Yeah, I mean, we have a list of like a biography list of all the presenters, speakers, keynote, and I'm not sure if we'll add the email there, but obviously you can search them and find.
I mean, yesterday I said we will share it, right? I mean, if no one objected, I guess it's okay.
Yeah, I mean, we wanted confirmation that everyone's happy to share their emails, but it's something that we can obviously add to that list. But yeah, we will have more of this documents that we will send out after the workshop.
Yeah, thank you.
Yep. Any other questions before Conrad close it and goes
Hold
for
on,
his...
just one sec. I think Lynn asked me a question earlier. I didn't get a chance to answer it, and yeah, maybe just very quickly.
Yeah.
You asked about the route to commercialization, and yeah, I think that's really because it's actually a very long journey when you bring a technology into the market, and because it's gone through many different phases of research and development. So I think the first thing you need to really have to be like a patient. So go through the proof of concept and then research and development, and then kind of simplify the whole technology to make it more user-friendly and also practical to use. And then you also need to face a lot of financial, political, and even technological barriers, and those need to be overcome in order to make it commercially viable. Yeah, I think that's my answer to that question. And the other one is the passive house. Yeah, I think the passive house is a good question. It's I think naturally, if you think more airtight buildings are more isolated from outside world, but actually, when you make the building envelope more airtight, you know how airtight it is, and the amount of unintended ventilation is minimized. That means you gain more control on the ventilation indoors, so you can achieve more precise ventilation. You can achieve the indoor environment can be more controlled, so you can achieve safe, healthy, and productive indoor environment. So that's my question to your answers. Thank you.
Thanks again. Okay, so I guess no more questions. Okay, so let's go for lunch, and Have a nice.
I'll go for my dinner. I'm hungry.
Oh, Conrad's going for his dinner, and
can we have a photo op for this session?
Okay, let's.
Okay.
If you guys are still here, I think if you can turn on your screen, cameras. Let's have a
closing.
Because this is the last one for the UK sessions.
Yes.
Okay.
Together mode.
For the IG.
I'll put it in together mode so that we can try that one.
Together mode.
We've got everybody now.
Shuang Yu, are you here?
I think she's left.
She already.
Yeah. Yeah.
Okay, she went out.
All right.
Okay.
This is okay. Who's gonna take? Okay, this.
I think.
We can all we can take and then we can share later.
I can do my ready. Already 1, 2, 3. Smile. All right, I think I have it.
All right.
All right, thank you for attending. This is the last session for the UK side. So there's gonna be one again for China, but it's gonna be in morning in China. It's gonna be in the I think at 1 a.m. in the UK, I think. So thank you for the organizers. I think the session will be recorded and the links will be sent out so we can review the recording of all sessions. And I hope that everybody had learned something from it and hope for more collaboration between the researchers. And this, I think, is very useful for these times, all of the research teams that were presented. So hope to see you anytime soon, either virtually or face-to-face. So thank you all. All right.
Thank you, guys.
Good. Yeah, thank you. Goodbye. And
thank you. Have a nice day. Bye-bye.
Bye-bye.
Goodbye.